Hi everybody, it's Miss Austin and I'm going to be going over the Unit 6 Lesson 1 problems, and we're just doing 1 through 4. You might be doing these on Desmos, you might be doing these on the digital PDF, or you might be doing these in your book. I'm going to be doing these in the book by hand. If it's on Desmos, it might have the transformation tools, and you could also check your work with that. All right, number 1, it says reflect triangle ABC over the line x equals -3. So x equals -3 is this line right here. So first of all, I can see that point C is on that line. So if the point is on the line, it's going to stay there. A is 2 away, so I'm going to go 2 away over here. Call that A prime. And then B is 1, 2, 3 away, so I'm going to go 1, 2, 3 away. There's B prime. And I'm just going to lightly sketch in this first one. Okay. Then it says, translate the image by directed line segment from 0, 0 to 4, 1. So what they're basically saying is, here's 0, 0, and here's 1, 2, 3, 4, 1. So they want you to shift this whole thing up 1 and over 4. So each of these points, I'm going to do what this directed line segment did, which went up 1 and over 4. So I'm going to use a different color now. So this one, I'm going to go up 1 over 4. 1, 2, 3, 4. That's my C double prime. A prime, I'm going to go up 1, 1, 2, 3, 4. And then B, I'm going to go up 1, 1, 2, 3, 4. And I might try to be a little bit more precise now. Use a ruler. And what are the coordinates of the final image? Well, A double prime looks like it's 3, 1, 2, 3. B double prime is 4, 0. And C double prime is 1, 1. All right, we're just practicing transformations today, and we have them in the coordinate plane, x-axis, y-axis points. Number 2, 3 line segments form the letter N. Rotate the letter N counterclockwise around the midpoint of segment BC 180 degrees. Describe the result. Now, some people might be able to visualize this. I want to actually try to perform it. So I'm going to get a piece of paper, and I'm going to outline this so I can see it underneath the paper. Yeah, tracing paper would really be good. And in the middle, I'm going to find the middle of this to the best of my ability. So I already traced this, right? Now, 180 degrees is when, and I'm using this as the point, the center. 180 degrees, excuse me, if you draw to the point that you're rotating, and then it's going to make a 180 degree angle. So see how that's a straight line? So that point D is going to get rotated until it lines up to here. So I'm just going to put my pencil here, and I've got this lined up underneath, and I'm going to rotate that D until I see that it hits A, and I've got it kind of highlighted underneath my paper. And I can see that it's lined up, and now what do you notice? My goodness, it's the same exact shape. Look, here's that letter N. That line that I drew in right here, that was just to show me the 180 degree angle. So rotating this 180 degrees, when I take that and rotate it there, because that's 180 degrees through that point, show you one more time, results in the same letter N. Because D becomes A. Okay, number 3. Triangle ABC has coordinates A is 1, 3, B is 2, 0, and C is 4, 1. The image of the triangle after a sequence of transformations is here, A prime, B prime, C prime. A is negative 5, negative 3, B is negative 4, 0, and C is negative 2, negative 1. Write a sequence of transformations that takes this triangle onto this triangle. So you might remember when we were doing this earlier this year, one of the easiest strategies was to map one of the points onto its image. So I noticed that I like this point. It's not the only one you could do. You could line up A to A prime, C to C prime, but I like that right there. So I am going to move point B from 2, 0 to negative 4, 0. So that's my first move. So I'm going to move triangle ABC from 2, 0 to negative 4, 0. And I'm actually going to do that. So that would be, let's count how many that moves it. 1, 2, 3, 4, 5, 6. So now that goes here, so that's going to go over 6. There's my new A. And then C would be over 6. 1, 2, 3, 4, 5, 6. So let's just kind of sketch what I have. So that was by moving everybody along this directed line segment from here to here. Now, what do you notice? Take a look here. What would I have to do to get this shape onto this shape? I would just need to reflect it across the x-axis. So step 2, reflect across the x-axis, right? Because this point's going to stay. See how that one's 1 away? So that one is 1 away. See how this is 1, 2, 3? This is 1, 2, 3. Okay, so move this triangle from directed line segment 2, 0, negative 4, 0, and then take that and reflect it across. This is the x-axis, that line right there. All right, number 4, prove triangle ABC is congruent to triangle DEF. There are different ways to do this. Today in our lesson we talked about, two triangles are congruent if, well, we have our shortcuts that we've learned this year. We have SSS. If all 3 sides are the same length, we can prove they're congruent. We have 2 sides and an angle in between. We had ASA and we had AAS. Now, in a coordinate plane, the easiest thing to do is going to be to prove the sides are the same length. So if I can prove that all 3 sides of ABC are congruent to DEF, then I will prove that these 2 triangles are congruent. So, first of all, in a coordinate plane, if segments are perfectly horizontal or vertical, you can just count. So hopefully everybody sees, look, AB is 2, and so is DE. So AB is the same as DE, which is 2. I don't have to show any work for that. Okay, now, the other sides of the triangle are not perfectly horizontal or vertical, so you're going to have to do some work. Well, today in our lesson, we talked about using Pythagorean theorem. Now, this is going to get a little confusing because I'm going to be drawing a lot of things on this coordinate plane. So do you see this right here? I'm going to make it if I want to find the length of that, I'm going to create a triangle. Look at this. I'm just going to right here draw here to here. Whoops. Right, I just created a right triangle, and this one that I'm looking for is the hypotenuse. But I can count that, and I can count that because they're perfectly vertical and horizontal. So I could do Pythagorean theorem. So I'm going to show my work over here. So, well, this is 1, 2, 3, 4. And then this is 1, 2, 3. And if I do Pythagorean theorem, that'll tell me how long this is right here, which I'm trying to find. Right? That one right there. So let's go ahead and do Pythagorean theorem. So that would be 3 squared plus 4 squared equals, I don't know, squared. That's 9, and that's 16. 25. That's what the side squared is, so I take the square root. So that missing side is 5. So this green line is 5, which is AC. Let me write that. So I've got AC, I know is 5. Now that also corresponds, look, can't you tell? We're going to hope that one's the same right there. So we would make a triangle out of that one. Look, 1, 2, 3, 1, 2, 3, 4. It's got the same 3 and 4. I don't need to show my work again. Look at that, 3 and 4. And that DF is that green segment again. If I do Pythagorean theorem, I'm going to get the same thing. So I can go ahead right now and say that AC is the same as FD, or DF, I probably should have said that in the other order, but it's okay. 5. So far I've got two sides that are the same. Now I've got this side right here. Let's use a different color. Use the orange highlighter. Now I need to find this side, right, which is the same on both of these. Now, what are you going to do? Make a triangle out of it. Take a look at this. That's 1, 2, 3, 4, and 1. So I'm going to draw that over here. That's 4 and 1. And that hypotenuse is that orange one that I just drew. So if I do Pythagorean theorem, and guess what? Look at this one. It's the same here. I'm going to turn this. Look. That's 4, 1, 2, 3, 4, and 1. So that orange segment on both those triangles, if I create triangles out of those, it creates the same Pythagorean theorem problem. Probably don't even have to show it because the fact that it's creating those triangles, but let's just go for it. So 1 squared plus 4 squared equals I don't know squared. That's 1 plus 16, 17. So I take the square root. So that missing side is the square root of 17, right? 4 and 1. But when I do it on this triangle, look, same thing. 4 and 1. If I find that orange line, it's also going to be the square root of 17. So there's my third side. So I have CB is the same as FE, which are both the square root of 17. So now you have all three sides. Side, side, side. Since all three sides are congruent, these triangles are congruent by side, side, side. All right. I hope that helped, and I will see you soon.